Okay, let's add the last tab to the stat tools called Analysis of Variance. I will push that one over. And let's add it to the list. Add a tab for it in the program. Okay, and let's see what that looks like. App.py. Now, here's the Analysis of Variance tab. We're still going to use the bivariate sheet, but we're going to be looking at different groups. So we could do Analysis of Variance with just men and males and females, but Analysis of Variance is meant to be more than just two groups. So I have this group that's A, B, C, D, A, B, C, and D. So these four box plots, you can tell that they're not exactly the same, but they're not horribly different. So Analysis of Variance is looking to see, is there a difference between the groups? My eyeballs say probably not. They're probably okay, not extremely different from each other. So a lot of these things are going to look very similar. We start with these two columns. Bivariate tab, here's your data set that gets pulled in. We're dealing with heights, and we're going to do groups. We could easily change this to weights. And there's your box plots for the weights. Again, not extremely different, but there is some differences. So you have the average of all the weights is 165. The average of the group means is, if you look at each group separately, ka-chunk, 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 you can see that there's some differences. Now we have this hard line right here, and then we want to look at the difference between what's happening between the groups and what's happening within the groups. So you have the sum of all the squares of between the groups, 3 degrees of freedom because there are 4 groups, and the sum of the squares within the groups, within with a G. I need to take that G off of there. That's weird. I'll have to find out where that is. There's not supposed to be a G. It's just supposed to say within. And degrees of freedom 96. What we're looking at here is there are 100 items total, and 1 off of each group gives me a degrees of freedom 96. And then you got your mean square, your F score, and then your p-value, alpha. Your critical value is a 2.6. Our F score is not bigger than that, so we wouldn't reject the null hypothesis of them being the same. And then here we go, and there's my curve. If the p-value is small, then I would say one of the groups is different than the others, but I don't have enough evidence to say that here. Okay, now let's go look at the code and see if I can figure out where that G is. Control F, width in, there it is. Take that G off of there. Okay, let's start up at the top. You got all your libraries that you're pulling in. We don't have a title. Is that true? Yeah, no, there's ANOVA right there. Let's see, so we have the sidebar, data or statistics. Oh, I didn't look at statistics. So we can pull in data, or we can just do straight up statistics of the data. That's from the Analysis of Variance tab in the Google spreadsheet. So there is an Analysis of Variance tab. Your groups, how many in each group, the mean, and the standard deviation. If you just had summary statistics of the groups, we can do analysis of variance from that too. All right, back to this. Oh, back to our data. So we pull in the Google spreadsheet, the bivariate tab. Let's see. We pull in the data frame, numeric columns, non-numeric columns. Let's see, we can, pick what we're going to do the analysis on. Let's see, you describe the data, and you group by the category that we had. So we had it by groups, so it grouped by groups. That's this, A, B, C, D. And if you switched it to, say, like gender, then it would group by gender. Let's see, where was the group by? Group by the category, and then the means, and then you do the Plotly chart. That actually carries, that becomes our box plots. See the box plot right there. By category, quantitative variable by the category that we choose, and then plot the box plots. The hard line that was down below broke the columns up into a 5-1. Guess we don't need the 1. And then, let's see, create your data set. That makes our little table. Fill in the items in the table. You got your between row and your within row. Some people call this the treatment, and some people call this the error. And then you have your data frame, and then we're going to plot the graph, so we can see that below. And let's see, template, and then plot that curve that's down below. X values are the F scores, and the Y values are based off of the F distribution. And then if you go to the statistics tab, it's very similar. You're going to pull your data from the Google sheet called ANOVA. And then we're going to build our data set from between and within, and throw in your data. Got your hard line down below. There's another G we got to get rid of. Build your little data sheet there, and then we get down and we plot the curve, the F distribution curve. Okay, that is the last tab of the data distribution. Let's see if it, oh, it did take the G off. Okay, good. This is the last. I'm going to update the GitHub, and then in the next video I'm going to show you how to upload this whole program online so anybody can use it. Update. Commit that to GitHub. Sync the changes. And we'll end that video, and then I'll do one more video to show how to put this whole program online so someone could use it.